Hello, this is Mr. Wyrick. I'm here to talk to you today about Lesson 13.1, the first lesson from Chapter 13 over Probability and Statistics. In this one, we're going to be talking about representing the sample space. So different ways that you can display all of the possible answers that there are going to be for a situation, or all of the possible outcomes. So the first definition you need to make sure you have in your notes would be sample space. It's all the possible outcomes. Typically, and for the homework on this one, it's going to be the list, the table, and the tree diagram. You may or may not have dealt with a tree diagram before. It's fairly straightforward. It looks like this. It's basically every time something happens, you have, let's say every time something happens, you have three options. You can go with option A, B, or C, and then it happens again and again. You can go with option A, B, or C. So you show like this. So either you could choose A, B, AC, BA, BB, BC, or CA, CB, and CC, and talk about what's going to happen in each one of those outcomes. So you kind of combine those into what it would look like in the final. You can organize it in the table, but you've seen tables before. You talk about there are this many of these, there are this many of these, this is the way it can go, or you can just list them all out. And sometimes, though, if you go to list, you can miss things, which is why it's helpful to have a tree diagram where it would be better organized. There's a two-stage experiment that you need to take down. They talk about that again more in detail on page 916, but basically a two-stage experiment, something is going to happen twice. For example, you flip a coin twice. So it's not just, I'm flipping a coin, what are all my possible outcomes? But I'm going to flip a coin twice, or I'm going to flip two coins and see what happens. I'm going to roll a die twice, or a pair of dice 2 times, whatever it is. You're going through 2 different stages. If it just says multi-stage, then that means it's 2 or more. So maybe we're going to flip 3 coins. Maybe we're going to choose different options for a hamburger. There's a nice tree diagram there on page 916 of a tree diagram for choosing options on a hamburger, and it's just yes or no on each one, but it means there's a lot of different combinations. Most of you have probably seen the Whataburger commercial where they talk about how many millions of options that you have with the menu, but some of that is just you can get a burger plain and dry, you can get a burger with ketchup, that's completely different. You can get a burger with just mustard, that's also completely different. You can get a burger with ketchup and mustard, so that's another option. It's talking about, when we're talking about sample space, we're talking about all of those things. What are the different ways that we can go through this? The fundamental counting principle. This is something you need to take down. It's on page 917. Make sure you have it in your notes. It's the number of outcomes in the first stage times the number of outcomes in the second stage times the number of outcomes in the third stage, all the way down to the number of outcomes in the K stage for however many stages you have, for K number of stages. So if it's 4 stages, you go 1, 2, 3, and 4. If it's 5 stages, you go 1, 2, 3, 4, and 5. And you take all of those options that you have and you multiply them by each other to find out the total number of outcomes that you could have. So again, if we go back to their example of the burger, you've got the size of the burger, small, medium, or large. So there's 3 outcomes there. You've got cheese or no cheese, so that's 2 options there. You've got pickles or no pickles, so that's 2 options there. So that's 3 times 2 is 6, times 2 is 12. So there are 12 different possible ways that you could put this together just by choosing a different size of the burger, cheese or no cheese, and pickles or no pickles. If we add in the tomato component, which I think they have on here, then that adds another 2 on here. So it'd be 3 times 2 is 6, times 2 is 12, times 2 is 24. So there are 24 different possible combinations that we could have based on choosing the size, cheese or no cheese, pickles or no pickles, and tomato or no tomato. So you just multiply those through there. That's pretty much it on this one. It's just talking, again, it's just talking about how many possible outcomes do we have, what are some different ways that we can represent that. It's some important introductory information before we get into some of the more difficult ways to calculate the probability of something happening. So we have to say this is everything that could happen before we start picking out specific ones and saying, okay, there is this much of a chance of this happening. Okay? On the questions today, I do want you to get into those higher order thinking. So we are going to do 6 through 26. If there's something in there that doesn't make sense, make sure to raise your hand during class, come in with a question, come in during tutorial time, find me outside if I'm on duty, whatever it is, and we'll see you then.